So for my final clip, I'm going to be covering moments of inertia. Now these are very similar to moments of mass. If you take a look at the equations, the only difference is that they have y squared and x squared instead of y and x in them. So what does the moment of inertia mean? It's basically inertia, so how hard it is to accelerate an object, but in rotation. And in general, the moment of inertia is equal to mass times distance squared, distance from the center. And this makes sense. You have a high inertia when something's far out. Think of a figure skater. When they have their arms wide out, they'll spin slowly, and when they tuck their arms in and have a low distance and low moment of inertia, they'll begin to spin very, very quickly. So what's the difference between I sub x and I sub y? Well, let me draw it out. So let's say you have some planar lamina, like this right here. I sub x is going to be how difficult it is to spin around the x-axis, so this way. And it makes sense that it's y squared because it's the distance from the x-axis. And the same thing for I sub y. It's how hard it's going to be for this to spin around the y-axis. And of course, it's going to use x distance because x is the distance from the y-axis. So finally, there's this thing called the polar moment of inertia. And it is denoted by I naught. And it's simply I sub x plus I sub y. And it kind of gets its name because if you add these two equations, then you would get x squared plus y squared in this position, which you could sub to just be r squared. So I'm not going to do an example for these simply because it's so similar to finding the moment of mass. It's just y squared instead of y. So I'm sure you'll be able to do it. And then Julian's going to finish off the lesson.